one way of solving systems of equations algebraically. So far we have only done this graphically. And so I need us to make sure that we understand that there's three options. You can have one solution, no solution, or infinitely many solutions. And this is a theme that we've seen when solving equations and solving various types of inequalities. So we're remembering that a systems of equations is at least two equations with at least two variables. Okay, so these two are lines that have something with, with a y and an x. And so we have something having one solution has two lines, they intersect at one point, and where they intersect, that is the solution. Okay? So if we have parallel lines, they have the same slope, but they have different y-intercepts. They are never going to cross ever, ever, ever. So there is no solution. So there's no coordinate point that makes both of these true at the same time. And then lastly, we have infinitely many solutions. So all you might see is a blue line, but if you look closely, there's a little bit of red here, there's a little bit of red here, because what had happened was these are two lines that have the same slope and the same y-intercept. So the lines are the same, so they're intersecting everywhere. So that means every single point that we plug in is going to make it true. Okay? So we started off talking about things graphically, but now we need to make sure that we understand how to do stuff algebraically. So our first example, so we're making sure that we were definitely turned to our packet. Our first example says 2x plus 7y equals negative 1 and negative 6x minus 7y equals negative 11. So we're looking for a coordinate point that makes both of these true. And so when we look at this right here, the problem is that we have two variables and we don't know how to solve something with two variables. So our goal is to try to get it so that there's only one variable. Okay, so when we do this method called elimination, we're just going to add these things together. And draw a line right here, and I'm just going to add these things together. So 2x minus 6x is negative 4x. Okay, 7y plus negative 7y is 0, so those y's go away. So we're eliminating those y's. Is equal to negative 11, or negative 1 plus negative 11 is negative 12. Okay, so this is great because now we have an equation with only one variable, which is up here we had two variables, which is why it was difficult to solve. Okay, but these canceled each other right out. So right now we want to get x all alone. So we can solve for x by dividing both sides by negative 4. So we're going to get x is equal to 3. Okay, so we so far have found what x value is going to work. So now in order to find y, we need to just plug it into either one of these equations. It does not matter which one we plug it into. So I can plug it into the first one. So 2 times 3, because remember I'm taking the x value and I'm plugging it in here because it says 2x. Plus 7y equals negative 1. So our whole goal right here is to find the y value that's going with the 3. So we have 6 plus 7y equals negative 1. I need to get y alone, so I'm going to subtract 6. So I'm going to get 7y equals negative 7. Therefore, y must equal negative 1. So what that means is my coordinate point is 3, negative 1. And I should check to make sure that that definitely works. So I'm going to take my coordinate point 3, 1, and first I'm going to plug it into, or 3, sorry, negative 1, and then I'm going to plug it into my first equation. So we're just checking that our answer makes sense. So 2 times 3 plus 7 times negative 1 equals, so is this going to be true? Equals negative 1. 2 times 3 is 6 plus 7 times negative 1 is negative 7. Okay, 6 plus negative 7 is negative 1. Negative 1 equals negative 1. Yes, this works. Okay, so that's what we're doing first, and now we're just plugging it into this one here. So we're plugging in the same coordinate point because what we're suggesting is that if we were to graph these two things, they're going to intersect at the point 3, negative 1. All right, so we have 2. Oh, sorry. I looked at the wrong one. All right, so we have negative 6 times 3 minus 7 times negative 1 equals negative 11. So negative 6 times 3 gives us negative 18. And then we have negative 7 times negative 1 gives us positive 7. And now does that equal negative 11? Negative 18 plus 7 is negative 11. So yes, negative 11 equals negative 11. Check. So we just checked our answer. So our answer is the coordinate point 3, negative 1. Perfect. All right, so that was the one that's like in the example box, and now we're just going to do one more that's in your packet together. So this is number 1. So we have negative 2x plus 4y equals negative 10, and 5x minus 4y equals 13. So when we solve this right here, the directions would be to solve this system. So you're looking for the coordinate point where that works for both of them. So it's where they would intersect if we graph them. So I take them, I'm just going to add them together. So negative 2x plus 5x is going to give me 3x. 4x minus 4x gives me, 4y minus 4y gives me 0. So these just cancel each other out. Equals, and then I have negative 10 plus 13, so that's 3. So now I want to solve for x, so I get x equals 1. Great, I found my x coordinate, and now I can find my y coordinate by plugging into either one of these right here. So the last time we plugged it into the first one, so this time I'm going to plug it into the second one. So over here, I'm plugging it in. So I have 5 times 1 minus 4y equals 13. So why we're doing this? Because now we know what the x is going to be, so we need to find the y coordinate of that line, or of that coordinate point. So we get 5 minus 4y equals 13. I need to get this alone, so I subtract 5, subtract 5. We get negative 4y equals 8. So y is equal to negative 2. So my coordinate point is 1, negative 2. And so what that coordinate point means is that is a coordinate point that makes both of these equations true. And if I were to graph them, this is where they intersect. So just making sure that I'm going to check my answer and making sure that I'm right. If I plug it into that first equation, I get negative 2 times 1 plus 4. Now I'm going to substitute in negative 2 for y. I don't know what this was all about. Equals negative 10. Maybe. Hopefully. So negative 2 minus 8, does that equal negative 10? Yes. This is negative 10 equals negative 10. Okay? So this coordinate point makes this a true statement, and then we just want to check that this coordinate point also makes this a true statement. So we're going to have 5 times 1 minus 4 times negative 2. Does that equal 13? So we get 5 plus 8 equals 13. Yes, 13 equals 13. Alright, so what that means is this coordinate point makes both of these true statements. This is where these two things, these two lines, if they were graphed, would intersect. Okay, so when we're solving a systems of equation, we are looking for where they intersect. If we got an example where, well, actually we're going to talk about that in class. All right, I hope that you have a good day.